Okay, good morning, everybody. My name is Andy Turner. I'm one of the technical team here at EPCC who helps look after users on ARCHER2. And this course we're running today is essentially the introduction to ARCHER2 course, but for software package users. So that's generally people who aren't compiling their own applications, rather they're running packages that are already installed on the system. And there's quite a few of these available on the system. So this is a large number of users use the system in this way. So what we're going to cover today is what the ARCHER2, a brief overview of what the hardware looks like on ARCHER2 and what that means for you as a user, how to access ARCHER2 and transfer data and all those sorts of things you might want to do on a day-to-day basis. What does the software environment look like? How do you access software, particularly pre-compiled software that you might want to use for while you're using ARCHER2? Writing job submission scripts using the ARCHER2 scheduler, which is Slurm based, and we'll cover more of that this afternoon. How to be a good ARCHER2 citizen, because it's a shared system, so everybody has to behave appropriately so they don't affect the system. For the people, we do as much as we can as the system ourselves to try and make it insulate different people from other people, but there are still ways you can impact other users. We'll talk a bit about that. How to check what resources you've used, look at historical usage records and things like that, and what the next steps are where you can get further help from ARCHER2. Please do stop me and ask questions. It's difficult for me to share my screen like this and do see the chat at the same time. I can sort of do it. So you can type things in the chat and I will try and answer them there, but it may be easier just to, if there's only a small number of people here, it's easier probably just to unmute and shout out. It's probably the best way to get my attention during these sessions. What does this, what other things do I need to say? So in terms of the schedule, we sort of assume, in terms of prerequisites, we sort of assume that you've used an HPC system before. So you're familiar with connecting with SSH and logging into systems. You probably know you should know what a batch scheduler is, and the one we use on ARCHER2 is Slurm. And you should be reasonably familiar with the Linux command line. You should also be happy editing plain text files in a remote terminal, e.g. using Emacs, VI, or something like Nano, all of which are available on ARCHER2. The schedules here were started a little bit late, but I don't think that's a big problem. The aim is about 20 past 10:30. We'll have a half-hour break for me to get a cup of coffee, and then we'll have a bit of a session. So the first session is all about connecting and making sure that everybody can connect who's here before we go on to actually using the system. After the break, we'll have a look at the ARCHER2 system, the software environment, stop for lunch, and then in the afternoon have a look at this. The main body of the work is looking at the scheduler, and then there's a few bits and pieces after that. We're scheduled to run till about 3:30. There's a good chance we'll be finished earlier than that, I think, given with the amount of material. But we wanted to make it long enough that people, if they ask questions, we've got time to stop, have a look at what people are interested in, and make it as useful as possible to you. So the only other thing I would say is so two things I'd say. One is around the code of conduct. We expect everybody to essentially be excellent to each other. So using welcoming language, being respectful of different viewpoints and experiences, and showing courtesy, respect to other course participants. So the full code of conduct is available here via this link. If you feel somebody, including the instructors, are violating this, then please do let us know. If it's an instructor, you might want to not let me know directly. So there is a form that you can complete to be anonymous if you wish. Course structure, we use a carpentries methodology. If you've ever been on the software carpentry or data carpentries course, you may recognize this. And essentially, we don't have slides and practicals. What we do is we have this material in the browser. We all work through it together. and I'll type things in the terminal and then give you a chance to catch up and try that sort of stuff yourself. And then there's little exercises all the way through for you to try out. We're really keen on feedback and happy to improve the course. So during the course, there'll be opportunities to say things, and we can provide feedback at any point and stuff like that. Particularly if you have questions, it's useful for us to hear them, so we know whether there's bits missing, which we can include in future runs. And after the course, you'll get a sort of more formal feedback form, which you can fill in and comment on how you found the course and opportunities for improvement and all those sorts of things. What I will do as well now is I will put the link to the material in the chat here, because it's easier if you have that open in your browser. It makes it easier for you to follow along. You can copy and paste things into your terminal and all that sort of stuff. Okay, so unless if you have any questions, please just shout out. Otherwise, I will move on and go to the first section, which is just checking that everybody can connect to ARCHER2, and we'll talk about transferring data as well. So the main point of this session actually is to make sure you can log into ARCHER2 and your accounts are working and all that sort of stuff. Excuse me. So the first thing is to say is the ARCHER2 login address is login ARCHER2 AC UK. And to access ARCHER2, you need two different credentials. One is a TOTP, a time-based one-time password, which usually comes from an authenticator app, either running on a smartphone or alternatively you can use ones that run on laptops and things like that. And a passphrase protected SSH key pair. For an additional security measure, newly created accounts also use a one-time password received from the Safe Web Administrator Service for the first time they ever log in. And you'll see this because I've got a new account. I've never logged in it before. So I will go through this whole process of setting up the TOTP, setting up the SSH key, and retrieving the one-time, retrieving my first-time password for when I log in. Okay. So TOTP used to be, it used to be a thing that was more difficult to explain to people, but most people are used to it now from things like bank logins or the website logins or through Office 365 or things like that. Essentially, you have an app somewhere else that changes an access code every 30 seconds or so, and you link the app on your mobile device or on your laptop to your ARCHER2 account using the initial seed. This is a key. It's usually it's a string of letters and numbers, but it's usually available as a QR code to simplify the process, so you don't have to type a long string of letters and numbers in, though you can if you want to do that rather than use the QR code. And this allows the app then to produce the code to the maximum ones known by ARCHER2. So when you create a connection with ARCHER2, you need to register the TOTP. Oh, that's a typo there. See, it's TOP instead of TOTP. You need to register the TOTP access in a suitable app. Excuse me. Instructions for doing this are available online within the safe documentation here. But actually, what I'll do is I'll show you how this actually works on ARCHER2. On ARCHER2, actually, you only need to enter the TOTP thing once every 10 hours for each account. On top of TOTP, you need an SSH key. So you can create an SSH key, and I'll show you how you do that as well. There's a documentation on the ARCHER2 documentation about how to create SSH keys and all that sort of stuff. And then, so once you've got the TOTP and the SSH key pair, you can log in for the first time, and you'll also need the initial password. But let's have a go. I'll demonstrate it from my account, then I'll let you all hopefully have a go and make sure everybody's connected. And if you get stuck or have questions, we can help you out. So what I'm going to start with is doing the TOTP code for my account. So what I'm going to do is I'm going to bring up SAFE, which is the EPCC Web Administration Service for the HPC systems we use. This is I was already logged into SAFE, which is why it showed me this here. And under the login account button, it will list all the login accounts for different machines associated with your username. I have absolutely loads because I have multiple accounts on ARCHER2 and on other systems that we have at EPCC. The one I'm going to look at here is this TA130AT at ARCHER2, which is the account associated with this course we're running today and a bit tomorrow for the software developer side of things. So you'll see at the bottom here, it says a multi-factor authentication token must be set to log into this account. This is because I haven't set the TOTP thing yet. So there's a button associated with my account here, which is set MFA token. So if I click that, what I get is the QR code or the key, and the key number, which I can enter manually if you want. But what I'm going to do is actually get my phone. I'm going to open my Authenticator app, and you'll be able to see this bit, of course. And I'm going to add a new method, a new authenticator, and I'm just going to scan the QR code. So it's done that on my app. It's given me a code that I can enter here. Now I've scanned that. So this is just the 6-digit code from my app. It will be different from yours. So now that credential's set. Okay, so it says up here now the MFA token set, that warning's disappeared. Okay, so that's the first thing I've managed to do. The other thing we need is an SSH key. So I'm going to create an SSH key too. And for that I need a bash terminal. I'm just going to go to temp. I've got an empty directory here just so I don't get things confused with other things. And I'm going to use the SSH keygen command. I'm going to give it my type RSA. And I can never remember. I don't do this very often because usually you set up a key once. So I'm actually going to look at the ARCHER2 documentation to remember the exact options. So it's the SSH keeper minus TRSA, and it's minus C. It's a comments thing. I just want to put my email address in that, so it's fine. So I'm going to do that, and it tells me it's storing a public-private RC key. Now you can save it to the default place if you don't already have a key. I already have keys there. I don't want to overwrite them, so I'm going to save it into this directory. I'm going to call it ID RSA course for whatever reason, and it's asking to enter a passphrase. So this is just like a password, but it's associated with your key. So I'm going to type something there, and it's going to ask me to do it again. Okay. Oop. Oh, that's a bit weird. So it didn't like that. So what I'm going to do is I'm going to do it again. This time I'm going to give it the full path. And what did I call it? I called it ID _ RSA _ course. Okay, that worked that time. It obviously didn't like the alias of the tilde up the home directory. I just have to give it the full path instead. It gives you this random op thing. And what I end up with here is two files: the private key part, which is just the one with no extension, and the public key part. The public key part is the bit I'm going to add to safe for my account. I'll show you how to do that now. What I'm actually going to do is I'm going to print out the contents of it. You can see it's just essentially another thing that's a string of letters and numbers. So the easiest way for me to do the safe is just to copy that string. And then if I go to my safe login account, there's an add credential button here. So if I add the credential, it says SSH public key, which is what I want. So next, so you can actually upload the file, but I'm just going to paste in the string instead. Okay, so this is the key it's added here. I already had one by default, but I've got a new one now as well for this account. Okay, so I have two things now. I have my SSH key, and I have my linked TOTP. go from the authenticator. The final thing I need for the first time I log in is the one-shot password from Safe, just to make sure I've got that. And that's here, this view login account password. And again, that's just going to be a random string. So I'm going to just copy that to my clipboard, like that. And then I'm going to try and log into ARCHER2. So I'm going to do SSH minus, sorry, here we go. SSH minus I gives the path to the private part of the key, not the public part. And then you give it username at login archer2.ac.uk. So my username is TA130AT. And the path, the private key is just in this directory, so I can just give it that. So it is TA130AT at login.archer2.ac.uk. And so it'll ask me for the passphrase for the key, which is the passphrase I entered when I created the key before. Hopefully I entered that right. And now it asks me for the TOTP code, which I go and look at my authenticator app, and it should have a number there. And finally, it asks me for the one-shot password, which I'm just going to paste in. And it asks me to set a new password. I'm like, oh, okay, I can do that, but I won't ever need this again, so it doesn't really matter too much. Okay, and then I'm logged in to ARCHER2, like that. And I've got no files here or anything like that because it's a brand new account. Okay, so what I'll do is I will give everybody 5 minutes or so just to make sure they can log in. I'm going to put up a poll in the interface so that and you can answer that to check that everybody's logged in successfully. You might have done this beforehand, before the course. That's great. If you've already connected and can do it, just tick yes in the poll. All I want to know is that everybody has connected successfully to ARCHER2. If you run it into any problems or have any questions about access, then please just let me know. So I managed to connect, so I'm going to click yes. And I'm just going to give people, like I say, 5 minutes to try and connect. Like I say, if you have questions or you want me to go over what I did again, then I'm happy to do that. So Robin says, I'm getting permission to deny public key. That usually means either you've not registered the key in Safe or you're not pointing to the correct location for the key when you try to log in. So for example, if I just did SSH TA130AT at login.archer2.ac.uk. I've forgotten to point to the location of my key and it's not in the right direction, so I get that exactly that same error because I'm not pointing to the right place for the key. And remember, it's the private part of the key you need to specify. Oops. Not the public part. So it's not the .pub bit of the key, it's without the .pub on the end. Okay, I got straight in that time without having to ask my passphrase because a Mac automatically adds your key to what's called an SSH agent, so you don't need to add the key passphrase again. And the TOTP code you only need to enter once every 10 hours if you're logging in from the same host with the same account name. So I didn't need to enter the TOTP code again to get back in. So people managed to get any I can't see any more responses to the poll, so I think it sounds like people are still struggling a bit to get that. Have we managed to get past the permission denied public key problem? Or does that still exist for you both, Robin and Dong? No, the LDAP password is the one-shot password. So that's in the view login account password on your safe account page where you set up the key and the TOTP code. When you're asked to choose a new password, you either need to choose something with lots of special characters in, or a reasonably long phrase, like a sentence, or 4 or 5 words strung together, or something like that. Just all lowercase is doable too. The shorter it is, the more special characters like capitals, numbers, and things like that. Show again. Show which again, the thing about the permission denied, or the thing about the LDAP password? The LDAP password, if it's that, is view login account password on your account page on the safe, where you added the SSH key and you did the. Okay, right. So it depends where your key is. You'll get that error. So if I exit out again, so when I just use the command on its own, like that, that's exactly the error I see. But if I point to where the private part of my key pair is, using the -I option, in my case, it's in this directory, and it's called ID RSA course, not with the pub on the end. Then that gets past the permission denied. Permission denied usually is I don't have the right key, is what it's saying. So either you need to point to the key using the -I option when you log in, and you need to make sure that the key you're using is registered in safe, is listed in this account credentials section for your account in safe. Does that help? Yeah, if you can point actually to the location where your key is, that's usually the right thing to do. SSH -I. Okay, so we've got 2 people. Shrewtree, I haven't heard anything from you, but you haven't answered the poll. Are you struggling with something, or have you not had a chance to try yet? Okay, I'll give a couple more minutes here, and then Dong, if you're still not quite got there, what I'll do is I'll ask one of the helpers, either Nathan or William, to chat to you directly, so you can like paste things into chat and things like that, to try and get this working for you. We could also set up a breakout room where you could share screen, or when we stop for the break, we can share screen and have a look at if you're still seeing problems. Okay, fine. So you've got past the key thing. Hopefully you can give it the TOTP, then give it the one-shot password, change your password, and then that should be that, and you're in. So what I'll do is I'll stop the poll. I'll carry on with this initial section, so we can get to the break. If anybody's still not in by the time we get to the break, then we can help you out there. Right, so let me get rid of that, and I will go back to here. So once you've logged in, oops. Okay, fine. So the MFA still needs set up. The TOTP code needs to be set up on the account. Thanks, Willie. Once the other bit of this session is we just want to talk a bit about data transfer, because obviously, as well as logging in, you'll often want to transfer data up to ARCHER2 for your use of the system, and download data as results from whatever you've been doing, whatever type of calculations, modeling, or simulation you've been doing on the system. There are a number of different data transfer mechanisms, and the one you choose depends on the amount and the structure of data you want to transfer and where you want the data transfer to. Excuse me. It says the three main options here are these two things, so that looks like a typo as well. Really, the two main options are SCP, which is a standard way to transfer small to medium amounts of data off ARCHER2 to any other location, or rsync, which you can use to actually synchronize data between two locations, and if your data transfer fails, you can automatically pick up where you left off and things like that. So rsync is typically more robust, though the command line syntax is a little bit more complicated than just using SCP directly itself. There are examples of this in the ARCHER2 documentation, how to use the two tools and what to do with them. I will just show you what that page looks like here. So there's a lot of stuff about the storage on Archer and how you share data with other ARCHER2 users and things like that. And then this is the data transfer section here. So it talks a bit about SCP, and then it talks about rsync and how to use that. What we also mentioned is a thing called grid FTP, which allows you to do large power transfers to other locations that also have grid FTP installed, and also a tool called ARCHER2, which allows you to sync data directly into, for example, OneDrive cloud services such as OneDrive or Dropbox, and you can move data into those services using that one straight using that tool rather than SCP or things like that. So some people have found that useful. So in terms of the sort of the syntax, then you can look at the ARCHER2 documentation and understand how to do it from there. What I actually wanted to cover more in this first session was a bit more about the sort of data management and data transfer best practice. So the main points you need to think about, actually one of the things, that the key thing almost actually, is knowing what data you have and which is critical, which data do you need in a different location to do analysis, which data will be easier to regenerate rather than to transfer. This is essentially a data management plan. So it's always worth taking, and we'll come back to this over and over again throughout this course, taking a few moments to think about what you're doing and how you're using the system before you actually go ahead and use it. So yeah, and the one here is have a think about what your data is, where it might live, what the consequences would be if you lost access to that data, either through a file system failure. Some of the file systems on ARCHER2 are not backed up at all. So if you delete data by accident or there's a failure, then the data is lost for good. There's no way to retrieve it. But some of the file systems on ARCHER2 are backed up, but at lower capacity. So if you have critical data that you want to keep on the system, as long as it's smaller volume, then you can put it on the backed up file system, so that gives you some sort of protection. Or you could download data and store it offline in multiple places and things like that. But you really need to understand what the different bits of your data look like and what the costs are of losing it and regenerating it to be able to understand that. You should minimize the data you're transferring. Just transferring data is usually costly, both in actual time and connecting, but in your time. as well to actually manage the transfers and move the data backwards and forwards. So you probably want to minimize that as much as possible. Make sure you're only transferring the data you actually need to transfer. Minimize the number of files you're transferring. So for when you're transferring data, each individual file has a static overhead associated with it in terms of time, but it's essentially the latency. So it's usually much more efficient, especially if you have lots and lots of files, to bundle the files together into a single larger file, usually called an archive file, for transfer. And you can use things like tar or zip to do this. And we'll see a bit more about that later in a moment. And understand if compression helps or hinders. So many of these tools we'll talk about in terms of rsync, but also in terms of the archival tools, tar and zip, use compression and genuinely encourage you to use data values. However, in some cases, the time spent compressing the data can actually be longer than transferring the uncompressed data. Particularly when you're transferring data between two locations that both have large bandwidth available, so either, say, from ARCHER2 to another HPC system or to another large university server. You may be better just transferring it without doing the compression first. And finally, be aware of encryption overhead. So the S in SSH and SCP stands for secure. That means that the traffic over these protocols is encrypted. The data is encrypted, introducing a static overhead per file. This is another reason why you want to combine files. The issue can be minimized. So what you end up happening here is, instead of being constrained by the bandwidth available to you to transfer data, you end up being bound by the CPU and the processor speed in terms of doing the encryption instead. You can change that by changing the encryption algorithm to one that involves minimal encryption, and actually use one that's built into the processor in hardware, which is usually the fastest. So the fastest performing cipher we've done some tests, the fastest performing cipher that's commonly available in SSH or SCP or rsync or these things at the moment is this AES-128-CTR cipher, because it's built into the processor. It's built into most modern processor hardware, which makes it very fast. We're a bit short of time, so I'm not going to do this exercise. I'm just going to show you the solution, because we're a little bit behind here. So it says use the documentation above. Find the kind you use to create an uncompressed liquid archive file of all the data within a directory, and then what command would you use to verify the archive file you've created is not corrupt, so you can safely delete the original data. That's the other thing we haven't mentioned. When you create an archive file, you should always check that it's intact and uncorrupted before you delete the data that you use to create the archive. So in this case, you could use the zip command to archive the data. The -R option is used to perform recursively on a directory. So it says, do this directory and all the files and other directories within it. The -0 option specifies that the archive should be uncompressed. So you do zip -R, then this is the name of the output file you're producing, the zip output file, and this is the name of the directory you're creating the archive from. To verify the archive is valid, use the zip command again with the -T option. So you use zip -T, and then on the zip file, it should report back whether your file is corrupt or not. So I can probably do something I could just create some data to show you this. So the easiest way to do this actually is just to create some data by taking a copy of the GitHub repository of this course. So if I grab this course repo, and that will give me a directory with some data in it, which is here now. So I can do zip -0 -R, the name of the thing, .zip, and the name of the directory I'm zipping. Okay, so now I have the original directory and the zip file, and if I do zip -T and check the zip, oops, I've done something wrong here. That should be right. What have I done wrong? So let me look at the manual for zip, and I will double check What's going on with that option? Before that should be correct. SSST. Oh, so the T option is not the verified option. So that looks like another error in the in this. Is it minus capital T? It may well be. Let's try that. That looks more hopeful. Ah, okay, cool. So that's a typo in the documentation. Let me fix that while I'm here. If I just edit that, I can fix that. Right. Okay, so that should be fixed now. So yeah, I've checked that the archive is valid, so I can now remove the original directory, except that I need -r because it's a directory, so I need to be recursive. Okay, so mostly that session is about making sure people can connect. We're going to stop now at 20 past 10, and we'll restart again at 10 to 11. We'll go into a bit more detail about ARCHER2 itself, the software environment, and all those sorts of things. So we'll start back at 10:50 UK time. For people who haven't connected yet, where we can share screens and help you out here. So Don, did you manage to connect to ARCHER2? Okay, so your LDAP password's incorrect. So did you pick up the initial password from safe? So that's this password, where it might be different. It'll be different for you, obviously. But you use view login account password, and that's the password you use when I ask for LDAP password. Okay. So that's a bit weird. So what you can do is you can hit the password reset button here, and that will give you a new password to try. So you can do that. You try that for me and see if that fixes the problem. Okay, let's get started because we're past the time now. So the next two sections we're going to look at are just an overview of the hardware and how it all fits together on ARCHER2, and then the software environment available on the system. So in this first section on the hardware, we're going to have a look at what's available on ARCHER2, how does it all fit together, so you've got an idea of what the service looks like and what that actually means for you as a user. So ARCHER2 is an HP Cray EX system, but in common with most or all modern HPC systems, it consists of a number of different node types. Now, a node is, you can think of as equivalent to a machine, like your laptop or a desktop system. It's essentially an individual computer, and all HPC systems achieve the large performance by connecting together multiple computers to create a parallel system. And each of those individual computers is usually called a node on an HPC system. So on ARCHER2, there are a number of different node types. There's lots of different ones, actually. The ones visible to users, and the ones that you actually see, are the login nodes, like this one here, which I'm logged into. And you see if you ask for its host name, it's actually LN. You might be on a slightly different one. LN stands for login node. I'm on 03, but there's a few of them, so you could be on a different number, different one. The compute nodes, which is where calculations and jobs actually run. And we have the data analysis, which are also maybe called pre or post-processing nodes or the serial nodes. And that's where you can run through the batch system, long-running serial processes rather than parallel processes. All of the node types on ARCHER2 have the same CPU processors. So there are these AMD processors. There's two 64-core processors per node. So there's 128 compute cores per node. This schematic sort of the idea here is to show how it all sort of fits together at a very high level. So this is supposedly you as a user here, and use SSH to interactively access login nodes or to upload and download data. You can also use the data analysis nodes to upload and download data as well. They're connected to the internet. And available from both the data analysis and login nodes is the home file system, which is where I am now. I use pwd, which is my current work directory. You can see I'm on /home, and then the project name, and my username. But also mounted are the work file systems, which are fast parallel file systems, and we also have some solid state storage as well. And they are also available on the compute nodes. So the fast parallel file systems are available on the compute nodes, whereas the login nodes, the analysis nodes, have both the home and work file systems. The only way you get access to the compute nodes is via the batch system, via the Slurm batch system, by the scheduler. Okay, so you can't log into them directly unless you have a job running on them via the scheduler, and then you can access them using SSH as well. The key thing, or the key workhorse and power of ARCHER2 comes from the compute nodes, because there's a lot of them. So there's almost 6,000 compute nodes on ARCHER2. There's 5,860. This gives just over 750,000 CPU cores on the system, because each node has 128 cores. Most of these have 256 gigabytes of memory, but a small number have double the amount of memory. They're called the high memory nodes. There's only just over there's almost 600 of them. So it's only a small portion of the system, like 10% of the system. All of the compute nodes are linked together using the high performance HV Slingshot interconnect, which allows them to talk to each other with low latency and high bandwidth. And that's how the power of ARCHER2, the power of HPC systems works, is that you have lots of processors working in parallel. So summary of the nodes is there are two of these AMD EPYC processors, each with 64 cores. There are 8 NUMA regions per node. Actually, that's a bit of a simplification. There's more details on the hardware page, and I'll show you what that looks like in a minute. But the memory structure layout of the compute nodes is quite complicated. But at the top level, in terms of RAM, they either have 256 or 512 gigabits of RAM with high memory bandwidth, and then there's the interconnect as well. There are two interconnects two network interfaces per node. In terms of storage, there are 3 different file systems. We pointed out, well, there's actually sort of 4 different file systems, because we pointed out 3 of them here, which are the home disk, the work, and the solid state storage. But there's also this RDF as a service, which I'll mention a bit more further down. The home file systems available on the logger and the data analysis nodes, designed for the storage of critical source code and data for ARCHER2 users, backed up regularly off-site, and they support recovery of data that's been deleted by accident. There's a total of a petabyte of this type of storage available for across everybody, so that's shared between all users on ARCHER2. And everybody has a defined, every user has their own defined directory on the home file system. So it's usually home/home, and then your project ID, and then your username. One potential source of confusion is the distinction between the home file system, which is a storage system on ARCHER2, and your home directory, which is a Linux concept of the directory you're placed into when you first log in, that's stored in $home and accessed by the cd command. Okay, so your home directory is defined as being on the home file system, but the two things are not exactly the same thing. You view your home file system quota and use through safe. If we look back at the safe interface here, if I go to my login accounts again and scroll down to the one for this course, which is my TA130AT one, I can look at this and it'll tell me here what my usage is on the home file system, also what my usage is on work as well. And it will also tell me my quota, how much space I have actually able to be used. This isn't updated in real time, it's updated I think twice a day at the moment, so it may lag behind exactly what the data is on the system. So just be aware of that when you're looking at it in safe. Some large projects also choose to split their resources into multiple sub-projects, and these sub-projects have identified as prevented from the main project idea. So, for example, if there was an RSE subgroup of the T01 project, then the idea would be T01-RSE, and you may get a separate subdirectory on the home file system with your username that points to this separate space. Your home directory generally is not changed when you're made a member of some project, so you can need to change directories manually or change the ownership of files to make use of the different storage quota or allocation. This is only the case if you're in a very large project. And there's a lot of projects on ARCHER2 that just use the this base level and never go as far down as to have sub-projects. Also on the home file system is a backup. These full snapshots are taken weekly for the past 2 weeks and stuff like that. So if you're on the home file system here, you will see, you can find out which file system your directory is on with the command readlink -f$home. So if I do that, readlink -f$home, oops, if I could type it would help. It tells me I'm on home 2 here. So if I go to home 2, snapshot, okay, you can see the different snapshots here. So let's have a look at the most recent one, which is this hourly taken at 10:05 earlier today. So we can look in home and we are TA130, and so in here will be me somewhere, TA130T, and there's nothing in there because nothing's been saved yet, okay, because I didn't have any data in there when we look in there, so it's empty. But when the next one's taken, 11:05, in just a few minutes time, then it should contain this zip file, which has been created since the last backup was taken. And so if I deleted this by accident, I should be able to go and retrieve it, assuming it has been backed up. Unlike home, work file systems are available on login data analysis. Also, like home, they're available on login data analysis nodes, but unlike home, they're also available on the compute nodes. And unlike home, they're not backed up at all. So these file systems are designed for high-performance parallel file access and are the primary location jobs on the compute nodes will read and write data to and from. Excuse me. Based on Lustre, which is the parallel file system technologies, and there's total at the moment of just over 10 petabytes available across all users on work file systems. And similar to home, you have your own directory on the work file system at the same location. So if your username is a user and your project was T01, your home your main work directory would be at work T01/user. So if I print my working directory and instead of going to that, I go to cd/work. That takes me to my work directory where there's no data because I haven't created anything yet. Okay, but it's essentially the same structure as home, but with just /work at the front. if you're running jobs and they're having trouble accessing data, make sure you place it on the work file system. It's a really common error people make is to put their data in home and then try and access it for the compute nodes, and it just doesn't work because the home file systems are not visible on the compute nodes. And again, through safe, we saw you can see your home file system quota. You can also, as long as you're in the work directories, use this LFS quota command to see what your quota looks like. I can do mine like that. And it says I've used 40 megabytes, but my limit's 500 gigabytes for this project here on the work file system. Okay, so and you can show your own usage and all that sort of stuff with these sort of commands too. You are able to share data with other users on ARCHER2. We have special directories available as part of every project on all of the file systems, on work, home, and on the RDF file systems that have these sorts of special names. So work project ID shared. So I can look at that here. So we can go, C dot shared. So this is a shared directory that everybody in this project would be able to see data here, as long as the permissions were seen correctly, and anybody in the project can create directories and share data in this way by changing the permissions correctly. Okay. So that shares within the project. If you want to share to other projects on ARCHER2, there's shared directories from that, again, up one level. So here I am in the shared directory here. If I go up a couple of levels, there's also a shared directory here. The difference with this one is people who are outside project TA130 could potentially see data here too. That they can't write data, they can only read data from it. Okay, so if you need to share data across projects, you can do that, and that's available on all of the file systems, including the RDF file system, which is usually a high capacity file system for keeping large data sets over a long period of time. It's backed up, and the idea is that it outlasts the ARCHER2 service, so that when ARCHER2 is replaced, data on the RDF persists and then can be made available on the next national HPC service afterwards. Okay. So they're the main file systems. I haven't said anything about the solid-state storage, and that's sort of beyond the scope of this introductory course. If you have questions about the solid-state storage, feel free to ask in the chat, or you can look at the documentation which describes how you get access to it and how you use it. It has slightly different performance characteristics to the parallel Worcester spinning disk file systems, so it may be useful for particular workloads. In terms of software, system software anyway, ARCHER2 runs the HP Cray Linux environment, which is based on SUSE Enterprise Linux. We officially support Bash Shell for interactive access, shell scripting, job submission scripts, and the scheduling software is Slurm. We'll talk in more detail about Slurm a bit later on today. So as well as the hardware and system software, HPE, the vendors of the system, supply the HP Cray program environment, which contains a number of different compilers, parallel libraries, common scientific libraries, some debugging profile tools, some optimized Python and some optimized R packages as well. And all these are available through modules, and we'll see them in the next section here. It talks about differences from Archer here, but we're not going to talk about that because Archer's long gone. And you want to use that system. You probably want to use that system in the past, but there were some differences. Essentially, there are three program environments: the GNU compilers, the HP Cray compilers, and the AMD compilers. It supports Cray API, OpenSHMED, shared memory, and a global arrays toolkit, and pretty common sort of BLAS laypack or all that sort of stuff, that Fourier transforms and things like that. On top of this software that's provided by HPE, EPCC also install a range of modeling and simulation software, some additional software, scientific numerical libraries, data analysis tools, and some other useful software. So this isn't a complete list, but this is a lot of the common stuff that's used. So for materials and molecular modeling, things like CASTEP, VASP, which are commonly used, CP2K and NWChem, things like that. Engineering OpenFlow is obviously is one of the major packages there. Biomolecular modeling, GROMACS and NAMD and things like that. Potentially LAMPS. So I think we have LAMPS as well, but that's listed above. Some system modeling stuff, some additional software libraries, and some various software tools, including machine learning tools like PyTorch and TensorFlow and things like that. Some of these pieces of software are licensed. We do not supply licenses for software, so users have to bring their own licenses. So for example, VASP is a classic example of this. You have to pay for access to VASP. So if you need to bring your VASP license with you to use ARCHER2. The way it works generally is you go to Safe, you say, I want to use VASP from this user account. We check your license against the license database, and if it's valid, we can give you access. That's generally how it works for licensed software. More information is available in the ARCHER2 docs. I will show you here in the ARCHER2 documentation, as well as the user guide. There's lists of research software, software libraries, and data analysis tools. So if you click on this, it shows you the various different software libraries. Software available on ARCHER2 and software libraries and things like that. And we also support use of Singularity containers for single node and multi-node jobs. Again, that's beyond the scope of this course today. If you have questions about Singularity and containers, I'm happy to try and answer them for people. So key points, ARCHER2's got login nodes, compute nodes. It's got a number of different storage systems and a high performance interconnect. There's quite a lot of software already pre-installed on ARCHER2, and the system's based on a standard Linux SUSE with command line access, which we've already seen via SSH. You can also use things like Jupyter notebooks to run on the compute nodes. There's information in the documentation on how to do this, and yes, so you know that sort of access via sort of, notebooks or web-based interfaces is also available on the system. Okay, please do ask questions in the chat or just shout out if you have any. The next section, or the final section before lunch, that I'm going to run through is just talking a bit about the software environments and modules in particular. So this is going to cover how we access software and what it looks like. How do I find out what's available? How do you get help with software on ARCHER2? With the idea is that you can know how to access different software on ARCHER2 using software modules and know how to find out what's installed and where to go for help. So ARCHER software modules use something called LMOD, which is similar in operating. A lot of people who've used HPC systems before will be familiar with software modules in some sense. Some systems use something called TCL environment modules. Other people use LMOD. Excuse me. We even see some systems using a system called SPAC to make software available now. At the moment, we're based on LMOD, but we are doing work to make SPAC available as well. But the software modules on ARCHER2, as we've seen in previous lectures, some are provided by HPE, who are the vendor who builds and supplied ARCHER2, and some are supplied by some are provided by the CSE team, EPCC, who support the system. So when you first log into the system, what modules are actually loaded? So you start out with a and some specific you can see
Andy, sorry.
Yeah.
Sorry, Andy, your audio is breaking up quite badly. Maybe you could turn off your video to save bandwidth. I'm not sure, just an idea.
No, is this any better?
You're clear just now. Yep, that's okay.
Okay, fine. Sorry about that. Better, fine. Sorry. Okay, so module list will show the modules you currently have loaded. The list I have now might differ slightly from the list in the documentation because we've been through various upgrades, so the various versions of software have changed. But the things that are loaded that are usually useful for users to note are things like program Cray, which tells you using the Cray compilers. And what's the other one? So Cray mpitch is the MPI library stuff, and Cray libsci is a standard set of scientific libraries that include things like BLAS and LAPACK, standard numerical libraries like this, and various other ones for various bits of for these things like libfabric and xpmen are all low-level system modules to make sure that the hardware works correctly. When you compile, you're compiling for the correct hardware on ARCHER2. So what people have often come across on other HPC systems is you use module purge to get a clean environment to start from. And the way that the HP Cray program environment works means that that's a really not a good thing to do. Like, if you use module purge, it'll clear all of the modules as your system, and it's actually quite hard to get back to the working set of modules from that point. The easiest way to do it actually is to log out and log back in again and to get back. So we really strongly say do not use module purge on ARCHER2. If you changed your module set and you want to get back to the original, clean log environment that you have, then you can use the module restore command. That just gets back to whatever the default environment is when you log in. Okay. Or you can log out and log back in again to get your environment back. But really, you should avoid the use of module purge on HP Cray X systems like ARCHER2 because of this integration of the programming environment. So you can find out what software is available using the module avail command. So let's just type that. There's quite a lot available, so this is going to be a long list. Okay. There's various bits and pieces here. So these things that in the sections that are marked WorkY07 shared are things that are installed by the team here at EPCC. So these are things that have been added by us. So there's some Python stuff here. These are various libraries, scientific libraries. And then we get down here to the applications. So things like CASTEP and VASP and OpenFOAM and things like that you may be used to seeing. Some utility stuff for visualization, data analysis. You may recognize some of these things, GNU-plot, for example, and things like AmPowerView for visualizing data in Power. And then below that, you get to these things that are in opt Cray PE or /opt something or other. And these are the things that are provided by HP Cray as part of the program environment. So there are I/O libraries such as HDF5 and NetCDF. There's the mpitch MPI libraries. There's perf tools, which are performance analysis tools, which we'll talk about today, but I think William might be covering tomorrow with people who are staying on for that part of the course. Various scientific libraries, FFTW, for example, and things like that. Excuse me. And then things around for the compiler environments. These are different compilers, so Cray compilers, GCC, and things like that. And some other things for targeting different types of hardware and things like that. Generally, you don't need to change these things, except for in advanced cases, which we're not covering here. And then subsystem libraries down here, which we've already mentioned briefly. Okay, so that's the full list of modules available. Excuse me, I'll skip past that. If you want to look at what's available for a particular package, not everything is going to be listed using this module avail command, because some modules are not available until you load a prerequisite module. That's what happens with in LMOD versus TCL environment modules. It's a bit different. But there is this module spider command which allows you to search through all of the modules, both the hidden ones and the ones that are available. So we run module spider create netcdf to see what netcdf modules are available. It tells you what versions are available. It gives you some ideas that there might be some other matches here as well. You can get more detailed information by giving it the full module name, which includes the version number on the end. Okay. So let's do that. Let's use. Sorry, there might be a question there. So there are ways to do that. So I think, do we cover them later on here? Just let me just check. No, we don't. So yes, there are ways to do that. I will try and show it in a moment, Robin, once I get through this bit. Just at the end of this section, I'll try and I'll test that and see if we can do it. So if we use this suggested command at the end with the version on it, it gives you some slightly different information. Looks just being a bit slow. So it says you need to load all modules on any one of the lines below before the netcdf module is available to load. What this essentially says is you need to have a compiler loaded of some sort, which we already do because we've got CCE, and then you need to load an HDF5 module to make the netcdf one available. So what we could do is module load cray HDF5 and 112.2.1, which is the one listed here. And now if we do module avail cray CDF, it will actually appear, and because we've loaded this cray HDF5 module. And so I can load it now. Whereas if I did module remove, that removes it from my environment. It'll tell you that netcdf is not available. Okay, but you'd have to find it by spider. Okay, I can do module load. And both of those are available environments. So what that means is when I now compile, I can assume that HDF5 and netcdf are available as libraries when I'm doing my compile. Okay. The slight difference then from what people might use to if they've used TCL environment modules before is when you do module avail, it might tell you the module is not available or it isn't there, which is usually with TCL environment modules, it would be there and you'd be able to see it, but you have to use the module spider command with LMOD because it's got this hierarchical structure of module files available. Right, so we did that. We did that. Okay. Okay, so you load modules. We've just seen that with the module load command, and so we could load GROMACS, for example, which is biomolecular simulation software. Here it said it was going to replace stuff, but actually it doesn't do that anymore. So you can see that GROMACS is available, and now I should be able to do the GROMACS executable. It's called GMX_MPI, and because I've loaded the GROMACS module, that's now available to me here. Okay. ML is a shortcut for module list or module load if you give it a software name. Oops. So I need to give it a different special type of phone. Oh, openphone.org/org. Let's try that. Yeah, okay, so it did change things that time. And module list shows that open phones are loaded as well now, as well as GROMACS, because we didn't unload that one earlier. Okay. And so There are maybe multiple versions available of modules. So module avail GrowMax. Is there multiple versions of GrowMax? Okay, so there are two different versions. This one's got a D next to it, which means it's the default one. The L next to it means I've loaded it, which I did a minute ago. If I wanted the non-default version, I need to give it the full name of the module. Otherwise, I'll just get the default one. Okay. And it tells you now that I couldn't have both of these ones at the same time, so it's replaced GrowMax 22.4 with GrowMax 22.4 plus plumed. Okay, because I can't have both of them at the same time. And which GMX has got MPI, and now you get the plumed version rather than the standard default version. I've mentioned before, a licensed software, you can request access through Safe. So the way you do this is you log into Safe, you go to your login account, as you've seen before already, and you can click New Package Group Request. So if I look at my account here, there's a request access to package, and I can choose from the licensed software here. If I choose VASP 6, for example, it would say, please supply your email address to register for VASP 6 access with the VASP team. So in the details, I would put my email address, click submit, and then that would start the process of getting my license checked and hopefully access granted to VASP later, eventually, so I could use it on ARCHER2. Because at the moment, I can load the VASP modules, and so I've now got VASP 6 loaded. But if I do, it won't be. I can't use it because I don't have permission in this account. I haven't been granted permission to use VASP. Okay, there's something here about getting help with software. Look at the documentation. You can always ask the service desk, that sort of stuff. So Robin asked whether we can save our environment. So let me do module restore to get back to the default one. So that all looks good. That's back to the standard software environment. Say I wanted to have a default environment with GrowMax loaded in it. So every time I logged in, I could use the GrowMax, or I could have GrowMax available. So we do module load GrowMax. And I think then I can do, what I'm actually going to do is, oops, I can't tell. Okay, so it is module save. I don't know, I didn't want to save it to help. Module save GrowMax env. I'm just wondering where I think it's put it in L not D. Yeah, so there's those two weird help ones I created when I was trying to look for the help, and there's GrowMax env. Okay. So I go back home, I'm going to do module restore again. Sorry, let's do module list. You can see the GrowMax is there. Module restore. Module list again. GrowMax is not there anymore. I can do module load. Oh, it's maybe not module load, is it? I'm going to have to look this up because I don't do it very often. There we go. Okay, so it's module restore, actually. So this time I can just do module restore GrowMax. So why has that not worked? So something's gone wrong there. So let me have a look at what's in this file. So that should work. I don't understand why it doesn't, I have to say. So I haven't, you can see, Robin, that I haven't tried doing this in a while. So I expected that to work, but it did not. So that lists my environments that are available. Okay, I will go away and have a play with this a bit and come back to you as soon as possible. I'm sure this used to be possible and used to work, but I haven't tried it for a good wee while. Now, probably not since the system was upgraded before the summer this year. So this probably maybe hasn't been tested for a while. So there's always the workaround of you can just load the modules, right? If this doesn't work, this should work, but I don't understand why it doesn't at the moment. Okay. So where are we? So you can find more information here, right? So I already said that. So the software is all available from modules. You can request access to licensed software through the safe, and if you want to install your own stuff or there's something that's not listed there that you'd like help getting available in the system, then get in touch via the service desk, and that's what they're there for, is to help you out with that sort of stuff. So where are we? It says lunch now, but it's too early for lunch, so we've gone to the next section. But before I move on to the next section, are there any other questions about software and software availability on ARCHER2? No, sorry, I just muted briefly. We had the fire alarm test in the building, Anna. So rather than you hear that, I just muted. Okay, so we're well ahead of schedule, so I will go on to the next section, and I'll aim to stop hopefully about 12:15 or something. So this one says it's supposed to take, so it says roughly 30 minutes teaching, 20 minutes exercise, so we may get through this before lunch, or we may just have to stop halfway. It depends how we do. So this section is the bit where we get to actually run jobs and try and understand the scheduler. So what we're going to cover is writing job submission scripts, controlling jobs, finding out what resources are available. So the idea is that you understand how SLAM works, what components make SLAM on the ARCHER2 scheduler, and where to look for further help. So ARCHER2 uses SLAM, which is a piece of scheduling software to manage resources and how they're made available to users. This is to ensure that everybody gets a fair go, that the system has a high level of utilization, all those sorts of things. The main commands you're going to use with SLAM on ARCHER2, there are lots and lots and lots and lots of SLAM subcommands. So this is only scratching the surface. But the main ones we're going to look at are sinfo, which looks at the sort of overall state of the system and the nodes on the system. Sbatch, which submits a non-interactive, or what's known as a batch job to the scheduler. SQ to show what's waiting and what's running. Scancel to cancel a job if we need to. And salloc and the srun. So salloc can be used to submit interactive jobs. And slightly confusingly, you can submit interactive jobs directly with srun as well. And we'll talk about that when we get to it. But also srun is used within a batch job or an interactive job to start a parallel program. So if you've used HPC systems before, you may have come across commands such as MPI exec or MPI run, which launch parallel jobs. On some SLAM systems, and some systems running SLAM, ARCHER2 is one of them, then instead of MPI run or MPI exec, use srun. And that's the case for ARCHER2. There's lots of documentation on SLAM, particularly on SLAM and ARCHER2 in the user guide. In fact, it's probably the biggest section of the document, the biggest chapter of the documentation is the running jobs ARCHER2 section. It has lots of information on different ways of running jobs beyond what we're going to talk about here. But the main thing, the first thing we're going to talk about is finding out what resources are available. So the sinfo command gives you a summary of the current state of the system. So let's just type that and see what we get. You get lots of output. ARCHER2 is a big system. And there's various things here. I'm just going to scroll up. So each of them, so what you get is you get a row for each partition along with the node state. So there's a row for every partition and every state. Okay. So what you see is there's a partition called standard, and in that partition at the moment 627 of the compute nodes are in state PLMD, which means planned. That means they may be idle, but they've been assigned to a future job on the system. So it's keeping them either unoccupied or they can be used as long as they become free again in time for the jobs that are planned to start on them. Okay. There's one node in this state pomp, which just means it's out. And usually things with a star next to them mean that the node is unavailable for some reason. 82 nodes in drain, which means they're also out of the system. These are usually nodes that are waiting for hardware repairs or things like that. Same with these drain and DRNG here. There's 29 nodes reserved, so you can have a reservation of a set of nodes for particular purposes. So 27 of them in that state are not available in the general pool, and just over 5,032 nodes at the moment are allocated and running jobs. That's what the alloc state means here, and it gives you a list of all the nodes. These are the node names. Go scroll past that. There's lots of them. There's just 63 idle nodes. They're not running jobs at the moment. And then there's another partition, which is the high memory partition, which has the high memory nodes in with the same set. And then there's the final partition, is the serial partition that contains the data analysis nodes. And you see there's a different state here, which is mixed. Because most of the compute nodes on ARCHER2 cannot be shared between users. When you get a node, you get exclusive access to it just for your jobs, and nobody else can be on that node. The serial and data analysis nodes are different. They can be shared between users, so they can run multiple jobs per node, which may be run by different users, which is why you end up with this mix state here. Okay, so hopefully this is what I've sort of tried to explain here, and some of the states here. If you want to look at individual nodes, you can use sinfo -n, which says show the individual node state. -l means long listing, which gives more information. We can run that command, sinfo -n -l. There's going to be a lot of output because there are almost 6,000 nodes on ARCHER2, but it should just still work. And so output that, there'll be about 6,000 lines here. And it will tell you a few things about the nodes. In fact, what I'm going to do is I'm going to pipe it into less so we can see the top of the output. It gives you a line for every node. And obviously the number of nodes will be 1 because it's a line for every node. It says which partition it belongs to, what the current state is, how many CPUs are on the system, this STT I'll explain in a minute, and how much memory is available. Okay. So if we look at a standard compute node, this is the first one on the list, is NID 001000. It's allocated, so it's running a job. It says it's got 256 CPUs, which might be a bit confusing because I said earlier that each of the nodes have 128 cores. And the reason it's listed as 256 here is because it's listing logical cores, not physical cores. Each physical core on ARCHER2 can host 2 hardware threads. So they end up being these 2 logical cores. So this is 256. But in general, most people only use the physical cores. So they only host 128 processes or threads per node. And you can see this STT is sockets, cores, and then threads. These are the hardware threads available on the node. So there's 2 sockets, 2 processors, 64 cores per process, and 2 hardware threads per core, which ends up being the 256, because 2 times 64 times 2 is 256. Then it lists how much memory is available. And you can see here that this is not the same as the total amount of memory on the node, which I said were either 256 gig or 512 gig. And this is because some of the memory is always used for operating system processes. So you never have access to that full 256 gigabyte. You have access to a subset of it, and this is what Slurm is listing here. Yeah, what is the amount you actually have access to? And then there's some other information about weights, priorities, and features. This available FE is features and stuff like that. The reason may be filled in. If a node is down, it might tell you why that node is down, for example. There you go. So there you go. There. This node is down because there's a problem with the BIOS. Okay. Yeah. You could look through the list and look for high memory nodes if you wanted. I just scroll randomly up here. The high memory nodes. You see they've got 4, 5, 6, 704 rather than the 22, whatever we were saying before, 227 number. Okay. So that shows you the state of all the nodes using STInfo, so you can get an idea of what's going on the system. And it says, let's look at the resources available to computers. We've just done that here in this. So are they what you'd expect? Well, sort of. As I've mentioned, it shows 256 CPUs. That's why I've explained why that is. And it says that there's less memory than you might expect. I've already explained why that is the case as well. Okay, so now we're going to move on to actually submitting jobs and making things run on the ARCHER2 compute nodes. So as with most other schedulers, a job submission script has a header section with the shell specification and options to the submission command, which is SBatch in this case, followed by the body of the script that actually runs the command you want. So in the header section, SBatch, options to SBatch are prefixed with hash SBatch in this way. So here's the simple example script that runs this XT-high program, which shows process and thread placements on a compute node, and it runs it across 2 nodes. So we can step through the various jobs one by one. So the first line sets the shell interpreter to use for this script. This should almost always, well, should always be bin bash on ARCHER2. It's the only shell interpreter that we actually support on the system. I think there are people out there using different things, but they're not guaranteed to work and see slightly different behavior. You're happy to try them, and we're happy to take queries on them and try and help you out. But if things don't work, we'll generally ask you to go and use bin bash instead, because that is what's supported on the system. And some of the options we're providing are a name for the job, that's the job name, how many nodes we want, how many processes, usually MPI processes, we want to run per node. So 128 is 1 process per physical core. Excuse me. CPUs per task is how many. It's actually set to stride between each of these processes. If you're fully populating a node with 128 processes, then this will usually be 1. If you were doing something that was like hybrid MPI plus OpenMP threads, this will usually correspond to the number of OpenMP threads per MPI process. But we can talk about that. If people have questions about that, I can talk about that in a minute. Time is the maximum wall time for the job. Okay, so this is how it tells the scheduler what the size of slot it needs these nodes for. And if you get to the end of that time and your job's still running, the scheduler will just cut it off and stop it. It won't wait for it to finish, it will just stop at 10 minutes, and in this case at 10 minutes. So usually what people do here is give it a bit more than they expect the job to take, just in case things run a bit more slowly than expected and things like that. The account always has to be present. That is the budget to charge the job to. That is usually the same number as your project. In this case, it's TA0. In this case, the example is this TA082. R1 is TA01 for TA130 for our project. Right, I can see that here from my working directory. Your project ID is usually the same as your budget. Then you tell it which partition it's going in. This is on ARCHER2. This will either be standard for standard memory nodes, high mem for high memory nodes, or serial if you're submitting to the data analysis nodes, the serial nodes. And then the QoS, sometimes referred to as the QoS actually stands for quality of service. There are a few of these available on ARCHER2. I'll show you them in a minute. In this case, on this course, we're going to use short, which just allows for very short jobs up to 20 minutes, but guarantees quick turnaround time for the jobs, so they run almost instantaneously. So that's all the options to the scheduler, and then the rest of the stuff in here is just commands to run, as you would normally, just Linux commands to run command line. So we load a module, XT-high, which makes the XT-high executable available to us. We're going to set the OMP num threads as 1. That's always something you should do in a batch submission script unless you're using multiple threading, multiple OpenMP threads, because some of the scientific libraries will automatically thread to the total number of cores that they find on a node if you don't explicitly set OMP num threads, and this can kill performance if those cores are already being used for all the bits of the calculation. And then finally, we use srun, which is our equivalent of MPI run or MPI exec or ARCHER2, so it's the parallel executable, which is XT-high, and we give srun these additional options. I will come back to those in a minute. But first of all, so everybody can do this. So hopefully you'll be able to do this as well. So what we're going to do is we're going to move to the work directory. Because remember, all the data we want on the compute nodes has to be available in the work directory rather than home. So first of all, I'm going to switch to my work directory, which is empty. Then I'm going to create a job submission script. You can use whatever editor you want. I'm using VI because that's what I'm used to. You can call your job submission script whatever you want. I tend to use the to use .slurm so that I know that they're slurm of job submission scripts. But that's not, doesn't have to be the case. That's just what I choose to use. And then I'm going to copy this and I'm going to paste it in here. Okay, to make my job submission script. The thing that I'm going to change is the account ID because it's TA130 hours. Okay, so I've changed that. I'm still going to use 2 nodes, 128 MPI processes per node, no threading, so just 1 for that. It's going into standard partition, standard memory nodes, and it's going to the short QoS, so things will run quickly, and we're going to try and run XT-high. Okay, just let me, right, so I've saved my job submission scripts, and now I have my job submission script ready to go and ready to run my calculation on the system. I said I would mention QoSs, but let me skip that for a moment and just come back to it. So now we're going to submit the job using the sbatch command. The sbatch command says, take my job submission script and put it into the queue and run it, and fit it into the queue and run it as soon as you can, essentially. So let me try submitting it with sbatch. So sbatch submit.slurm in my job submission script. And I'll come back and it'll tell me what the number of the job is for. So this is a unique ID for my job. Okay, and then I can use SQ to check how my job's doing. The problem is with SQ is if I type SQ, I see everybody's jobs, right? And there's so many of them that I would never, it's really difficult to find my job in that list. What I can do instead is use SQ --V, which says, just show me the jobs for my user. And if I do that, you can see there are no jobs, right? Which seems a bit weird. We just submitted the job. But the actual reason is that it's already run. It ran so quickly that I've taken too long and I can't see it in the queue anymore. Okay. And if you submit a job by mistake, or you suddenly realize there's an error in your job submission script and you want to cancel it before it runs, you need, as long as it's before it's run or while it's running, you use scancel to kill it. You can kill, or you can give other options, so you can kill all your queue jobs, for example, but not the running ones, with something like --user, give your username, which is contained in the user environment variable, and if they're in state pending, so that kills all my queue jobs, but not the running ones. Okay. So I said we'll have a look at the outputs in a minute, but I said I'd come back to talking about QoSs. So I'm going to scroll back up here. I'm going to go to the ARCHER2 user guide and go to the section in the user and best practice guide, which is called running jobs, which is the description of this layer stuff. In the table of contents down here, there is a section on quality of service, which are the different QoSs on ARCHER2. Okay. You can see there are quite a few of these. I've scrolled down quite a few of them. The one most people use is standard. That allows you to run a job up to 1,024 nodes, which is 1,024 times 28 cores, which I can't remember what it is off the top of my head. The maximum runtime is 24 hours. You can have up to 64 jobs queued, and 16 of them can be running. Okay. You can also, any one user can have a maximum of 1,024 nodes in use. So say if you submitted 64 1,024 node jobs, although you can potentially have 16 jobs running, you could only have one running actually at any one time, because that would use up your maximum number of nodes. There's a high mem for access to the high mem nodes, which has some more, which is slightly more restricted because there's less of those types of nodes available. There's a task farm QoS that allows people to run smaller jobs, but lots more, but more of them, essentially. So if you've got small jobs, but you want to run more than 16 at once, it can run up to 32 at once. There's the short QoS, which we just used, which has a maximum runtime of 20 minutes, maximum node size, job size of 32 nodes, more restrictive in terms of the number of jobs you can have queued and running, but guarantees turnaround quickly, because there are dedicated nodes for the short QoS, and people can't use them for very long. There's a long QoS, smaller jobs, but they can run longer, so they can run for up to 48 hours. And then, I guess, if you want to run a job larger than 1,024 nodes, you can use the large-scale QoS. That allows you to use up to the whole system, which is 5,860 nodes. You can only run for a short amount of time. You can have small numbers of jobs. We have the low priority QoS, which is uncharged. So it doesn't charge against your budget. It runs for free, but it has much lower priority than standard jobs. So if there's space on the system and there are no standard jobs left, then low priority jobs will run. So you can run jobs in this QoS for free, so extra jobs, but they only run if there's sort of space on the system or behind other higher priority jobs. So generally queue times are longer, or quite a lot longer often for low priority jobs. Finally, there's serial QoS, that's something special for accessing the serial nodes, and reservation is something special that's used for when people have reservations on the system. So there's quite a lot of QoSs here. Most people use the standard, most people use the short, some people use the other, and then quite a few people use log, but it depends exactly what type of jobs you'll want to run, what QoS you're using. So we've submitted SBatch, we've talked about SQ, and we talked about SCancel. So what's srun doing here? So I mentioned it's the equivalent of MPI run and MPI exec, and that's true of it. So what it does is it says srun in this case, in our job submission script. Let me scroll back up to the job submission script actually, because that'll make it easier to see. So you'll notice for srun, if you've used MPI run or something similar before, you may remember that you often specified the number of MPI processes to launch, be it 128, be it 1,000, be it whatever number. You can see here I haven't specified anywhere or in this srun command how many MPI processes I'm going to launch. That's because srun is part of Slurm. So what it does is, unless told otherwise, it takes the numbers from the SBatch options. Okay. So here srun says, oh well, they've asked for 2 nodes and 128 tasks per node, so 2 times 128, I'm going to launch 256 MPI processes. Okay. It takes these additional options which specify how to place those processes on the actual physical cores on the nodes. The hint no multi-thread says do not use those hardware threads we talked about. Remember we said when we looked at the output from SInfo, it said it had 256 CPUs. This turns off using the logical cores and only uses physical cores. So it says there are only 128 cores per node. Only use 128 cores per node. That's what that option is saying. This distribution option, and you can look into the syntax for the extra detail. What this actually says is place the MPI processes sequentially on physical cores. So MPI process 0 goes on core 0 on node 0, or node 1. MPI process 1 goes on core 1, node 1, and it just fills them up sequentially. When it gets to the end of node 1, it starts filling up in node 2. Okay, that's usually the most efficient placement of MPI processes. Though there are some cases where you might want to do something slightly different, but that's the default placement is the right thing to do. Okay, so this S rule says launch 257 MPI processes, do not use the logical cores, only use physical cores, and fill them up sequentially across all the nodes you've been given. Okay. And then, so we ran the job, it ran. Where did the output go? You know, how can we check what actually happened in our job, in our calculation? Well, it puts by default, unless you tell it otherwise, you can tell Slurm exactly where you want that data to go. Both standard out and standard error from the jobs are written to a file called slurm-jobid.out. So if I look in my working directory where I submitted the job, you'll see I'll have this slurm jobid.out file, which contains the output. So what I'm going to give you a moment is give about 5 minutes until about 12 o'clock. Have a go at running the job based on this job submission script. Remember, you'll need to change the account number on ARCHER2, and then have a look at the output and see if it's what you expect, and check you can do that. I'll put up a little poll just to make sure, just so people can report back when they've done that, so I know where people are up to. As always, if you run into any problems or have any questions about this, please just ask. And I'm happy to talk or answer the questions if we can. Okay, we're at midday. I can see somebody, Robin's managed to do this. Well, there's people running into problems, or is just working on it and need a bit more time? Does anyone have any questions on job submission stuff? I'll just give it 2 more minutes then, and then we'll carry on with this section. Okay, thanks, Nathan. Okay, so the M file that's being produced essentially has a bug in it. It's got the two of the modules that are loaded in the wrong order, so you have to do a manual fix, which is a bit of a pain in the neck. We can raise that with HPE and see if it's something they can fix, but I suspect not. So I suspect you could then produce an environment you could save, but you have to do some manual fiddling out with it to make it usable, which is not very pleasant. Let me see if I've got that error. If there's an error in this lone file. Oh, come on. So you are right. So there's a problem with XT high module file. So I did test this yesterday, and that worked. It's definitely still wrong. So I'm going to go and look at the module file itself. So, and that's because that's not me, of course. So I need my actual normal user account to be able to do this. Which is going to ask me for a TOPG code. Give me a sec. I can see if I can fix that module file. I'll probably type that wrong. No, got it. It's here. It was this, wasn't it? Where was the error? Line 61. Okay. It's just that. Okay, I don't understand why this isn't working. This is bonkers. And it worked yesterday as well. So what I'm going to do is I'm going to put in a quick check hack to fix this, or quick check to fix this. Yes, live demos are always a bit of a nightmare. So and then I will go away and fix it over lunchtime. So this is the actual path to the executable. Okay, so I'm going to bypass the whole module stuff and just do put it explicitly in the job submission script, which is the way of doing it. Right, so I'm going to remove my slurm.out file. I'm going to edit submit.slurm, and I'm going to change this to the actual path of the executable, which should just work. I'm going to put that in the chat as well, so everybody else can have it if they want. And I'm going to comment out the module load xt-high. And let's try submitting that again. This time I was quick enough to see it running. So you can see it's partition standard, it's got the name, my user, how long it's been running for, the two nodes, and it tells you which nodes are assigned to the job. It's finished now. Okay, fine, so it's worked this time. If you give it directly the name of the executable, I'm not sure. I need to go and do a bit more debugging of that particular module file to work out why it's not loading not loading correctly. What you should see, I'll just stop this poll. What you should see from it is it tells you that it's running on two nodes with the host name, how many MPI ranks are running on each node, how many OpenMP threads per MPI rank, and what the name of the executable is. And then it reports where each of the MPI processes or ranks is bound. So the first one is bound on node 0, rank 0, thread 0, and is bound to core. This affinity is tells us bound to core 0, so on through all those things. And if we go up to 128, then the next process will be bound to the first core on the next node, and so on and so forth. Okay, so that's the output you should see from the job. And I think that's what's listed in the solution as well. Yeah, so you see the same sort of thing in the solution here. Okay, so sometimes people might want to do what's called underpopulated nodes, and this is usually to access more memory or more memory bandwidth for processes. There are other reasons you might want to underpopulate, but they're the general, they're the major reasons is access to memory capacity or memory performance. Because the less processes you have on a node, the more memory you have per process, and the more memory bandwidth you have per process. And this underpopulation is achieved by altering the slurm options, typically by setting the ntask per node option to less than 128, and usually set the CPUs per task option to ensure the processes are evenly distributed across the node. So, for example, to half populate a node with processes, to give 64 processes per node instead of 128, you usually end up doing ntasks per node is 64 and CPUs per task equals 2. This says give me 64 processes per node and have a stride of 2 cores between the placements of each of these processes to make sure they're evenly distributed. If you did this, each process had access to double the amount of memory that it would if you had 128 processes per node. Usually, the product of n tasks per node and CPUs per task would be equal to 128 number of physical cores on the node. So above here, 64 times 2, probably the next place you'd go is 32 times 4, and so on and so forth. The next exercise here is to do the same job script, but run on 4 nodes with 32 processes per node, and run it with XT high and see if you get what you'd expect as the output. Of course, you also need to give the full path to the executable because the module files are not working. But you should just be able to modify your current JavaScript to do that. So as the last thing to do before we stop for lunch, I will give you that task. I'll give you 5 minutes at the moment to have a go at that. I'll put the poll up, and then in 5 minutes' time we'll stop for lunch and we'll talk about what time to come back. So let me put the poll up first of all. You can respond to that if you want. I won't do mine because I'm still sharing my screen, so it will show you the answer if I went and did it myself. But I'll give you 5 minutes, then I'll show you how to do it, and then we'll stop for lunch. So Don is asking if there's going to be a recording available after finishing this. So the answer is yes. We're recording at the moment, I hope. Yeah, we are still recording at the moment. Once this day is finished, then it just takes a little bit of time for the recording to be processed and put online. Okay, just 1 more minute and then I'll do the solution to this one and we can stop for a bit. Okay, let's have a quick look at how we do this one, and then we can stop. So I'm going to remove the previous output, just so I don't get confused. I'm going to head back my job generation script. So I wanted to use 4 nodes. I wanted to use 32 processes per node. And I wanted to get the stride right. So 32 processes per node means I want a stride of 4. So 4 times 32 is 128, number of physical cores per node. I'm going to do 4 nodes. But my own penum thread is going to stay as 1. Because I'm not using threading here, I'm just underpopulating. So now it's running, and it's running 4 nodes. That's a good start. Finished. So hopefully, okay. Well, Robin, you could just try it, see what happens. If you try to use more cores, then it won't work because it just won't. More cores than available than you reserve per node, because it'll just say there's not enough resources available. We're using less. Should work, but it might do something very weird. So this one's done 4 nodes with 32 MPI processes per node, and you can see that that's interesting. So it hasn't done the stride. Oh, and I know why. So here you go. So I've spotted an error here. So one of the other things, I was expecting this affinity to go in steps of 4 because I'd set the CPUs per task to 4, and it's not. But I know the reason why. It's because I forgot to do something else here, which may not even be in the solution actually. So we recently updated Slurm, and one of the changes we had was that the CPUs per task option from SBatch isn't being passed down to srun automatically in the new version of Slurm. So what you need to do is export an environment variable, which is srun CPUs per task equals Slurm CPUs per task, I think, off the top of my head. Let me try that and see whether that works first, and then I can explain what's going on. So that's still running, and that's finished. Okay, right. So that is the output I expected. So now you can see that process zero here, has an affinity for the first 4 cores. Process 1 has an affinity for the next 4 cores, so on and so forth. So what's happened is that this setting is not being passed down to srun. There are a number of different ways you could do this. I could have added here just added the option to srun, which is fine. That means I need to change it for every script. But the easier, more automatic way to do it is when you're writing your script is to always have this option in which says set the srun CPUs per task to whatever has been set in the calling job. Okay. So that's because of an update to Slurm. You need to do that. I will update the course material to include that as well. But the documentation already states this. The ARCHER2 documentation has definitely been updated with this new option. Robin was asking about weird integers. We can just try that. So say we wanted 30 per node instead of 32, right? I could do that. I still couldn't change this to more than 4 because otherwise I'd be greater than the 128. But this should still just work. So we're going to remove the old one. I think it should work. Oops, I've run it twice. Well, doesn't really make much wrong. And you look at Okay, so it just says I've got 30 each node, and it puts them each 4. So all that happens is you don't end up going across all cores on the node, because you only end up to core 119 instead of core 127 on the complete node. So the job will run, and it will do something as sensible as it can, but you may run into slightly funny things, particularly with memory access and memory performance, because you're not evenly going across numerous regions on a node. You see what I mean? So typically what you probably do, you might end up with strange numer effects. So it's often, it can often be difficult to get right, or to get right performance if you don't use things that divide by 1 to 8. Okay. So we're going to stop there. That's almost 25 past 12. We've got just a small amount of, this is lots of that. Yeah, there's just one last little section in this bit to go. In fact, what I'll do is I'll finish this and then we can stop for lunch actually, because this will take me less than 5 minutes and we'll finish at 12:30. So this CPUs per task stride we used above here to underpopulate the nodes can also be used to run hybrid MPI and OpenMP jobs. But in that case, instead of setting OMP number threads to 1, you set OMP number threads to the same number as the CPUs per task. And you also need to set this OMP places environment to cores to make sure that the thread binding is right from OpenMP. So for example, this job does 2 nodes, 8 MPI processes per node, and 16 OpenMP threads per MPI process. Okay, so we're underpopulating in terms of MPI processes, but then we use these options, and we'd need the this option as well here, which I'll add into the document, add into the course material. We add this option in as well, and we'll be able to run the hybrid executable. And if you ran this sort of thing, you'd end up with something that looks like node 0, process 0, thread 0 is bound to core 1, node 0, process 0, thread 1 is bound to the next core, so on and so forth. Okay, so it's exactly the same as underpopulating. It's just you specify the number of OpenMP threads as well. Okay, there's something weird here. Okay. Oh no, there's still the interactive jobs. So that's how we do OpenMP number threads, and we'll talk about interactive jobs when we come back after lunch as well. I will stop there because I want to cover that thing in a bit more detail. So that's 25 past. There's no point me carrying on because it's going to take like 10-15 minutes to do the interactive job bit, I think. So we'll stop there. What I'll say is, if people are happy, we can start again at 1:15. Is that okay for people? That's giving long enough for the people who want a full hour for lunch. Are they happy with just doing 45 minutes? Is anybody not happy with coming back at 1:15? Okay, fine. We'll do that then. We'll start back here at 1:15 and finish off the Slame section, and then do the other bits and pieces. And we'll be finished well before 3:30.